Our last lesson of the chapter is 9.8. We're going to be solving quadratic systems. So we've learned how to graph all of these different shapes. And now what we're going to do is learn how to solve systems of equations, but not necessarily just with linear or functions or straight lines like we did back in chapter 3. So we'll still use some of the same methods. We'll use substitution method. We'll use elimination method. But again, like I said, we're going to be trying to see where different shapes intersect. So maybe, for example, we would see where a circle and a line intersect. So we would find those 2 points of intersection. So here's an example. It says find the real solutions of any of each system. You may wish to use a graphing calculator to check your answers visually, because we can put these in a graphing calculator and see where they intersect and see if that's about the points that we get. But we don't actually have to graph these. We can just do this all algebraically. It's nice to think about what's happening, about what you would be graphing. For example, with that first equation, I see that y is being squared and x isn't. That would be a parabola. More specifically, it would be a parabola that is going to open to the right. And then I can see in the second equation, x is just a first degree, y is to the first degree. So that's just going to be a straight line. So what we're doing just, conceptually is figuring out where a parabola and a line are going to intersect. And that line, I didn't, show the slope of it or anything. It's not a horizontal line. But we would want to try to figure out where these are intersecting. So what we're going to do for this one is use the substitution method. And you may remember from previous lessons, what that means is we're going to isolate one variable and then plug it into the other equation. Well, this problem is kind of nice because x is already isolated in the first equation. So what I can do is just take that y squared minus 9 and plug it in for x in the second equation. So that what I would get would be y squared minus 9 in for that x, and then minus 4y minus 12 equals 0. And then we would need to solve this. So first I could combine like terms. I see I have this negative 9 and a negative 12. So that's y squared minus 4y minus 21 equals 0. And now that's a quadratic equation, so I'm going to need to factor in order to solve. So y times y is y squared. We have 7 times 3 will give us 21. We wanted to add to negative 4 in the middle. So setting each of these terms equal to 0 gives us y is 7, and here this term, y plus 3 equal to 0 gives us y is negative 3. But this is only half of the battle here, because remember, if we're finding where graphs intersect, those are points. It's a coordinate pair. So what we have in this case is the y coordinates of the 2 places where it intersects. So we do need to go back and find the x coordinate of each of these. What you can do is plug it into either equation. Doesn't matter. The whole point is that they're the same at that point. So plug into either, I'll just abbreviate EQ for equation. So if I know x equals y squared minus 9, I'm using the first equation. When y is 7, we have 7 squared minus 9, which is going to be 40. Same thing over here. We have x equals y squared minus 9, and we plug in negative 3. So we have negative 3 squared minus 9, so that's 0. And that's our answer. Those are the 2 places where those graphs would intersect. So that's the solution to that system of equations. Okay, same question here. Let's just think about for a second what these shapes would be, and then we will go ahead and solve again. So looking at the first one, x is being squared and y is being squared. We're adding the 2. This is going to be a circle. You could think about, dividing by 61 on both sides, and you'd have an equal radius. So I'm just going to make a circle to show us it's a circle. And the second one, again, x is first degree, y is first degree. So it's going to be some sort of line. I don't we're not going to think about what the slope is, but we're looking for where a circle and a line intersect. So again, we're going to use substitution method here. And maybe a little bit more work for this one because we need to pick a variable to isolate. So I'm going to look for one that looks easiest to isolate. I see that the x here just has a coefficient of 1, and it looks pretty easy to get by itself because I can just add the 2y and subtract the 7. So that's what I'm going to do here. I'm going to choose to isolate x. So x equals, like I said, if I add 2y to both sides and subtract 7, I get x equals 2y minus 7. So now what I'm going to do is plug that 2y and minus 7 in for the top x. So that's 2y minus 7 squared in this equation, and then the rest, plus y squared equals 61. So yeah, we got some work to do here because we're going to have to distribute this. Remember, 2y minus 7 squared is 2y minus 7 times 2y minus 7. So we have to do all of that distribution. So that's okay, let's do that. We got 4y squared minus 28y. Let's see, then we got, where did I do that? 28y, good. And then plus 49 when we multiply negative 7 and negative 7. And then, oops, I'm missing the squared on those y's. Let's put that back in there. Plus y squared equals 61. So let's combine some like terms here. I see I have the 4y squared and the y squared, so that's 5y squared. And then minus 28y. And then if I subtract the 61 from both sides to combine those like terms, I get minus 12 here. So again, we got a quadratic. We need to factor this. So we're going to have 5y times y will give us 5y squared. 6 times 2 will give us 12. And then we wanted to add to negative 28 in the middle. So setting these two terms equal to 0, if I set 5y plus 2 equal to 0, I get y equals negative 2/5. And then if I set y minus 6 equal to 0, I get y equals 6. Now remember, we're finding where these two shapes intersect. So those are points on a graph. So you've only found half the battle here. You found the y coordinate. You need to go back and figure out what the x is for each of these. Excuse me. So what you can do is just, use this equation for that isolated x. So x is 2y minus 7. So for this one, we got y is negative 2/5. So if we simplify that, we're going to get negative 39/5. Same thing over here. We have x is 2y minus 7. So we're going to do 2 times 6 minus 7 and get 5. And now we have the two places where these graphs intersect. Remember, it doesn't always have to be that it's intersecting in two places. So, for this one, we did somehow get like that we had the line going all the way through the circle, so it was hitting in two places. But you can think about scenarios where that wouldn't happen. Maybe it was a circle and they're just tangent to each other, so they're intersecting in one place. So I don't want you to think that you always have to get two answers necessarily. Okay, here we go. So now we're going to be graphing a x squared minus y squared equals 15 and x plus y equals 1. So we would be talking about graphing a hyperbola and a straight line. So let's do substitution method one more time here. Again, we can choose to isolate whatever we want. X and y look equally as easy to get by themselves here. Maybe I'll get y by itself just because we didn't in the other two examples. So let's get a y first. So I'll subtract 1 from both sides. I'll get y is 1 minus x. Now I'm going to plug that 1 minus x in for this x in the first equation. So in that first equation, we have x squared minus y squared equals 15. But now I'm plugging in that 1 minus x. So now we just do some simplification. So we have x squared minus, don't forget we're going to do 1 minus x times 1 minus x. So if we do that distribution, we'll do 1 times 1 is 1, Oops, that was an ugly one. Then we'll get minus x, that's minus 2x, and then plus x squared. And then remembering to distribute this negative all the way through. So we'll get x squared minus 1 plus 2x minus x squared equals 15. So let's go ahead and combine like terms here. What you're going to see is that the x squared minus x squared reduces to 0. And then we're going to just get negative 1 plus 2x equals 15. So I can just isolate x here. I can add 1 to both sides and get 2x equals 16. And then divide by 2 and get x is 8. So remember then, that's only half the battle. So this time we got the x coordinate first, so what we need is the y coordinate. Because we only got one answer for x, then there's only one place where these functions intersect. So here we just need to solve for y. Go ahead and use that equation that you already rearranged for y. So y is 1 minus x. So y equals 1 minus 8. So we'll go ahead and get negative 7. And there it is. That's the place where on our graph where these intersect. Last one is example 4. So same question here, find where they intersect, find the solution of the system. I wanted to show you one that's easier to use with elimination method, because I haven't done that yet. Remember, elimination method is just where we kind of stack these vertically and try to get one of our terms to cancel. Notice here that looks pretty easy. If I was to add these vertically, I would get 8x squared plus 8x squared is 16x squared. And the y squared minus y squared would reduce to 0. That's the point of elimination. You get to eliminate one of your variables. If I add 25 and 36, I'll get 64. And now it's just, a couple steps to get x by itself. I would divide by 16 on both sides and get x squared equals 4. I would take the square root of both sides and I'll get x equals plus or minus root 4, which is plus or minus 2. So that means I have 2 places where these graphs are intersecting. One where x is positive 2 and one where x is negative 2. Again, that's only half the battle here though. We still need to find out what y is. So let's go back to our original equations and plug in x is 2 and negative 2 into each of them. I think I will do that. I need a little bit more room. So let's do that one up here. So if I plug in 2, let's say we'll plug it into the first equation, doesn't matter which one. We have 8 times 2 squared plus y squared equals 25. So now I'm going to just, simplify this. So I got 32 plus y squared equals 25. If I subtract 32 from both sides, I get y squared equals negative 7, and then I square root both sides, and notice what's going to happen. I'm going to get an imaginary number. So we don't get a real solution from that point. Let's see if we get a real solution from this other point. So let's plug in negative 2. Hopefully you can see right away that this is going to be the same thing, right? Because whether you do 2 squared or negative 2 squared, either way there's still 4. So all of this algebra is going to be the same for the second one here. So I'm also going to get y equals plus or minus I root 7. So this problem says find the real solutions, if any, of the system. So this one has no real solutions. All right, that's it for the last lesson of the chapter. This is 9.8. Go ahead and check Schoology for homework.